So welcome back, Stella. Today we are starting with a chapter in physics called projectiles. So I'll first show you the different things we are going to see under this chapter. So this how we are going to be working. We shall see what is a projectile. We shall see the different types of projectile motion. From there, we shall see how to choose and orient the origin of reference of a projectile, because it's very important when you are studying a projectile motion. We're going to see how to determine the initial conditions of a projectile. It's also very important. And finally, we shall end up by studying the various types of projectile motions in order to determine one, the initial positions. That is, it's always denoted x0, y0. If you are in 3 dimensions, there will be a z0 inside here. So we use in most textbook is always called the OG0 vector. So we shall also study the different motions in order to be capable of determining what the initial velocity, the components of initial velocity, which are Vox and Voy. In most textbooks, is denoted by Ux and Uy, and the vector. These are the components form, and the vector is what? The vector U. We shall also determine the components of acceleration, which are the vector A, which are Ax and Ay. We shall determine the components of the final velocity, which are Vx and Vy, which corresponds to the components of the final vector V. We shall determine the components of the final displacement x and y. We shall determine the equation of trajectory. We shall determine the maximum height, which is h max. We shall determine the time taken to reach maximum height, t max. We shall determine the horizontal range, xr, and the time of flight. So we shall study the various types of projectile motions and determine each of these components. So when we shall be doing that, these are not things you should cram. You should not cram them. Generally, this is how, when you are given an exercise in projectile motion, this is how you tackle the question. You first come out with all of these components. Generally, you come out first with what? The components of initial position, the components of initial velocity, the components of acceleration, the components of final velocity, final displacement, and the equation of trajectory. When you come out already with this 1, 2, 3, 4, 5, you can already tackle any question that will be asked in the exercise. You understand? So whenever you are given an equation on projectile, first start by finding these five things. After finding these 5 things, you'll be capable of answering any question that will be asked in that projectile question. So without wasting time, let's dive directly into the A part. So what is a projectile? It's very simple. If they ask you in an exam what is a projectile, you will simply say that a projectile is it's any body of mass m, launch at its any body of mass m, launch in a vacuum with an initial velocity u, which is with an initial velocity u making an angle alpha with the horizontal, and that angle alpha is called the angle of projection. Let me define it back. A projectile is any body of mass m, launch in a vacuum with an initial velocity u, making an angle, that is the initial velocity, making an angle alpha with the horizontal, and that angle alpha is called the angle of projection. So that's how basically you can define what is a projectile. You understand? Now, let me give you some examples of projectiles. Example, let's say you have a basketball player This is where he has to shoot the ball. This is a basketball player who wants to shoot a ball inside this basket. The ball, when he shoots the ball will always describe what? A projectile motion. He will always describe, he will give it the ball a certain velocity u, which makes an angle theta with the horizontal. The basketball player, a basketball player shooting a ball into a basket, the ball he shoots will describe what? A projectile motion. The second thing, like for example, a football player who kicks a ball. A football player who kicks a ball, let's say these are the goals. When he kicks the ball will always describe a projectile motion. This velocity u, which makes an angle theta with the horizontal. The football player, when he kicks a ball, the ball will always describe a projectile motion. So those are two examples of projectile motion. Another example is a war chariot. Those cars that are usually used by the army during the war. They usually have guns in front here. A war chariot. When this war chariot will shoot the bullet usually describes a projectile motion. You understand? That will be the velocity u, which makes an angle theta with the horizontal. Is that okay? It can be theta or alpha. Is that okay? So I gave you the definition of a projectile. I gave you, these are three examples. So when a war chariot shoots a bullet, the bullet will always describe what? A projectile motion. So those are three real world examples of projectile motion. Now, if you take note, if you notice something, when I was defining a projectile, I said that it is any body of mass m launched in a vacuum. This means that whenever we are studying projectiles, there are some assumptions that we have to make. They are generally, I'll give you three assumptions that you generally have to make. The assumptions that we generally make when we study projectile motion. The first assumption is that the motion, the projectile motion, we assume that there is no air resistance when we are studying a projectile motion. That's the first assumption that's usually made. We assume that there is no air resistance. We assume that there is no air resistance. The second assumption is that we assume that acceleration due to gravity g is constant at each point of the motion. We assume that acceleration due to gravity g is constant at each point of the motion. And the last assumption is that we assume that the effect of the curvature of the earth, because the earth has a certain curvature. We assume that the curvature of the earth is a spherical body, so it has a certain curvature. You understand? We assume that the curvature of the earth does not affect the motion of the motion of the particle. You understand? So these are the three assumptions. We assume that the curvature of the earth does not affect the motion of the particle. So these are the three assumptions that you can usually make when you are studying a projectile motion. So in this video, we basically saw what is a projectile. I gave you three examples of projectiles, of projectile motion, and I also gave you three assumptions that are usually made when we study a projectile. So in the next video, we are going to see what are the different types of projectile motion. So see you in the next video.